Okay, so we have this set of test scores, and I've made these purposefully quite low in order to make this a little bit more interesting when we're trying to work it out. But we are going to look at Chebyshev's theorem, which is always true for every set of data. So that's important to realize that it will always work. Um, but let's take a look at how to show that a data set actually satisfies the theorem. Now, the first part of Chebyshev's rule says that at least 3/4 of the data lies within two standard deviations. So I've got the mean here and the standard deviation, and I've got my data. So let's go ahead and figure out what two standard deviations above and below the mean are. So my mean minus two standard deviations. We'll do that calculation. And then we'll also do my mean plus two standard deviations. And let's do those two calculations in our calculator. So for the first one, when I stick that into my calculator, I get 7.47. And for the second one, I get 120.43. Now, if we look at our data, all of this data, there's only one item that does not fall in this range from 7.47 to 120.43, and that is that 4. So that means 19 out of my 20 items, um, 19 out of 20, which is 95%, or we can reduce it to, well, we'll call it 95%. 95% of my data falls within two standard deviations. Now, Chebyshev's rule said that at least 3/4 or 75% lies within two standard deviations. And certainly 95% is at least 75%. So that first part has proven true. Okay, so the next part of Chebyshev's rule says that 8/9 or 89% lies within three standard deviations. Well, we already see within two standard deviations we have 95%. But let's say we didn't. We would just go ahead and do three standard deviations below the mean and above the mean. And we're probably going to get 100% of the data at this point. Let's do those two calculations in our calculator. And we get, for the first calculation, negative 20.77. And for the second calculation, 148.67. So notice that all of our data falls between these two values. So really we have 100% of our data lies in three standard deviations. So 95% lies within two standard deviations, which definitely fulfills Chebyshev's rule. And certainly 100% is at least 8/9 or 89% of our data that's within three standard deviations. So certainly that's true. Now, since we're already at 100%, all the rest of Chebyshev's rule is going to work out as well. But let's just pretend for a second that we didn't have 100%, just so we understand the last part of Chebyshev's rule. It says that 1 minus 1 over k squared, let's see if I can put that, of the data lies within k standard deviations. Okay. So in other words, let's say we let k be 4 standard deviations. So 1 over 1 16th, because 4 squared on the bottom would be 16, would lie within 4 standard deviations. Or 1 minus 1/16 is really going to be 15 over 16, would be within 4 standard deviations. So we could do a calculation for 4 standard deviations again, just like we did with these two, and show that at least 15 over 16, or whatever that is as a percentage. Let's see, 15 over 16 would be 94% of the data would be within 4 standard deviations. Now, we already know that 100% lies within 3 standard deviations. So certainly, um, that's at least 94% of the data that lies between 4 standard deviations. So this is how we show Chebyshev's rule, and it will always work. And make sure that on a question that asks you to show this on an exam, that you show your steps just like I've done here.